Hi guys, in this video we're going to talk finally about simulations and predictions. So a simulation, in order to obtain the probability of various events, we perform simulations. It allows us to represent the likelihood of a real-life event occurring by using an experiment with similar probabilities. So we talked about experimental probability earlier, but this method is typically used by researchers when you can't get the data or it's unknown. So an example might be tossing a coin, rolling a number cube, using a deck of cards to use and creating that random number generator for something you can't actually go collect data on. So let's brainstorm a couple of examples of that. On a multiple choice question, we know that if it's A, B, C, and D, there is a 25% chance of getting the answer correct. What is something else that has a 25% chance of happening? What could I use to make a simulation and find out some probabilities? What do you think of? So I thought of a spinner. What if I had a spinner with 4 outcomes? With 4 outcomes. What if I had a spinner with numbers 1, 2, 3, 4? Those match up to A, B, C, D. They're equally likely to happen. What about on the next one? There's an equally likely chance that a baby is a boy or a girl. So something that's similar to that. How about flipping a coin? You still have a 50-50 chance of a coin landing on heads or tails. So those are simulations we could run to predict, rather than waiting on babies to be born. That takes a while. We could flip a coin and predict what the gender of the baby is going to be. All right, so let's use that and then run this simulation for this one. A family has 4 boys, and the parents wanted to run a simulation with 10 trials to determine how likely that was supposed to happen. So a simulation we could have run that is similar, like I said before, I would run this simulation by flipping a coin, and then we want to label which outcomes which when we run this simulation. So I would say that heads is going to represent that boy, and tails is going to represent having a girl. So then I could run that simulation 10 times. Let's say I flipped a coin 10 times. And then how many times do I actually need to run that to figure out the likelihood of having a boy or a girl? We must flip it 4 times because they had 4 children. So this one we would say you would toss the coin 4 times to represent each of the children they had. And then record those outcomes. So say I flip it 4 times, I get heads, heads, tails, heads. We get 3 out of 4 there. But then there's 10 different trials that need to be conducted. 10 different trials that need to be conducted. So then we could find out our actual experimental probability. Does that make sense? Let's look at that with actually making our prediction. So on this one, please remember probability can also be used to figure out a future occurrence by setting up and solving a proportion. Remember, a proportion is a fraction equal to another fraction. So on this example, the probability of rolling a 6 on a number cube, so a 6-sided cube, is 1 over 6. If the number cube is rolled 50 times, then approximately how many times will a 6 be rolled? So we're going to take the one we know. This is our known probability. We want to know how many 6s we're going to get out of 50. So this is a proportion, a fraction equal to another fraction. And remember, we cross multiply. We butterfly those. So I get 6x is equal to 50. And then to get a variable by itself, remember we do the opposite. We divide. Because this is multiplying, we divide. And we simplify where we can. So x would be 25 over 3. Or you could write that as 8 1/3. It is approximately 8 1/3 6s will be rolled. Let's look at another example. So Ellie had a package of 15 candies, After opening it, she found out 13 candies that were not green. 13 candies that were not green. So I could write that 13 out of 15 were not green. Which means 2 out of that 15 were green. So if she opened 3 more packages, how many candies would she expect to be green? How many candies would she expect to be green? So, we want the green. We're going to use that fraction for the green. And then we want to figure out, what am I setting that equal to on my proportion? So she opened 3 more. 3 more. So she has 4 total boxes, and 4 boxes with 15 candies is how many I need to set that equal to. So 15 times 4 gives me 60. But she's wanting to figure out how many greens, so that's our unknown. We can make that any variable. I just always use x out of habit. Let's cross multiply. 15x is equal to 120. And remember, to get a variable by itself, we need to divide. So 120 divided by 15 leaves me a total of 8 green candies. In all 4 boxes, she got 8 green candies. All right, let's look at one last example. So when you're sending mail with the post office, there is an 80% chance it's going to end up where it's supposed to the correct recipient. That means out of every 10 letters, 8 of them are going to get there to the right place. So that means 2 of them are not going to the right place. If 430 letters were delivered on Monday, then what is the reasonable prediction for the number of letters that are delivered to the incorrect location? So we're going to use that 2 out of 10. 2 out of 10 do not go to the right place. But we know they delivered 430, so how many are going to the wrong place? Let's cross multiply. 10L is equal to 860. And if we divide out by 10, we can just cross out those zeros. And we find out that 86 letters went to the wrong location. Which is actually quite a few. But what about Tuesday? Maybe they did better on Tuesday. On Tuesday, it's reported that 500 letters were delivered to the correct location. So this time we should use the 80%. We should use the 8 out of 10. And based on this information, how many were delivered in total? So this time we know how many correctly arrived, and we need to know what was the total number delivered. But if we do the same thing, we cross multiply, and I get 5,000 is equal to 8x. It's okay that x is on the right. We're still going to just divide out that coefficient of 8. Divide out that coefficient of 8. So we find out that there were a total of 625 letters delivered that day. So I hope that helps. We can make some predictions going forwards with this, and we will see you in class to practice it.